Hello, my name is Kelly Diamond, and today I'm going to be talking about using Slicer for science communication and how to tell a story with digital dissections. And I have a QR code here so that if you want any of the links that are in this presentation, you can grab them from the PDF that you can pause and scan the QR code and get any of the links that I have in my talk today. So I always start all science communication activities with an introduction to explain who I am and that I'm more than just a scientist and how my audience can relate to me. So I try to introduce myself before I introduce my science, and something like, I'm Kelly. When I'm not doing science, I love being outside and playing with my four floops or taking naps with my four floops or something like that. Something that makes it easy to relate to someone who is not currently a scientist. The second thing you need to think about when you're doing outreach with 3D data is, what 3D data are you going to use? Ideally, you want to use your own data, but you might not have 3D data for your own work and you still want to be able to play around with it. Well, good for you. There's a whole bunch of different repositories that you can go and request 3D data for outreach for. I have the PDF of this, has all of the links that you need to try all of the different sources. I'm not going to go through them in detail. But no matter what, if you work on humans or fish or butterflies or plants, there's a repository out there that you can use that has 3D data that you can play around with outreach. The next thing you need to develop in your story, once you know what data you're going to use, is the actual story. Because if you don't have a story to tell and you're just going to go through and label the parts of the anatomy that you have, it's not super interesting. So some things that I like to consider when I'm thinking about how to develop an outreach story is, the first thing is, what take-home message or what do I want my audience to learn? So one of the things that I do pretty frequently is, how can a fish's teeth tell us what it eats? That's a question I start with, and I kind of ask that question at the beginning, put it in the back of their mind, and then work my way through the story so that by the end of the activity, they can answer that question. The second thing you need to think about is, who is your target audience, which I'm sure you've heard from other people in this workshop. So a lot of times I'm working with elementary school age children. So what I need to provide with them and what I need to talk about needs to be age appropriate, both in terms of making sure they understand the concepts, but also making sure that they can follow along. So piggybacking on that, you need to make sure, I need to think about, what concepts do I need to explain or introduce before I start talking about the anatomy and doing the actual dissection. So I need to talk about tooth shape. I need to introduce the species that I'm going to be talking about, talk about why they might be different, why they might be eating different things, and all of these different concepts that I'm not going to explain every detail if I'm talking to an elementary school class, but I'm going to introduce the topics, make sure that everybody's on the same page when we dive into the dissection. And then going back to the last slide, what specific images are you going to use? You might have hundreds of images of mice. What specific mice images are you going to use? So I use two images in my demonstrations. I use a CT scan of a piranha because almost everybody knows what a piranha looks like. So we have something to build off of. We have sort of the expectations built in. And then I like to use a CT scan of a batfish, which is, just this bizarre looking fish that most people have never seen or even heard of. And even if they have, they've definitely never thought about what they eat. So it's a really fun activity to incorporate a foundation of what the participants do know and build off of that to learn something deeper about these different animals. And then finally, I like to think about, why do I care about this topic? Because if I don't find it exciting, then I'm not going to be able to get other people to think it's exciting either. So for this specific activity, I think batfish are super cool. I might never actually see a batfish in real life outside of an aquarium or on a YouTube video, but I can look at a CT scan of a museum specimen and tell you all about what they eat, how they move, where they live. I think that's super cool. So the two parts of 3DSlicer that I'm going to cover today are volume rendering and segmentations. Volume rendering, you're going to need a slightly nicer computer with a little bit more visualization and computing power. If you don't have access to a nice computer, the second part, the segmentation part, you can do on a regular laptop. So I'm working off of a Linux computer in this first video, and I'm using the batfish just to show you sort of the piranha, to show you sort of what's going on. So here we have the layout and you can see the individual slices. I minimize those because what we're really interested in is a 3D view. So I go to the volume rendering module and I click the eyeball next to the volume button, or at least I try to. There we go. Now my volume, but it's a big black box. So I want to fix that. So if I go down to the advanced section and click it to be more open, I can change the scalar opacity mapping of my volume so that now the densities that I want to be able to visualize the bones are visible. Just to pause real quick and say that there are preset conditions. You could say select a preset if you're working with data that might be more humanoid. 3DSlicer is made for human-like data. So if you're working on human or primate data, you can use those presets. If you're working on something like fish data that's got really different densities than humans or primates, you're probably going to have to play with the scalar opacity mapping curve down here. Once I have the curve looking the way I want it and I can see all of the parts of the scan that I want to see, I'm now going to go play with some color. So I'm going to add a nice bright orange color to the higher density parts of my scan. And then by just clicking that button and then clicking this little square, I can change it to whatever color you want. You can be as artistic as you want. Click the point where it's a little lower density, and I'm going to pick a teal, very contrasting color, just to show the differences between the highest density and the more moderate density. And you can play, you can change how much orange or how much blue or add more colors. You can really go nuts. This is really where you can be as artistic as you want. But for this activity, I wanted to be able to visualize the most dense parts of the fish. That was a point that I wanted to sort of drive home with this activity. And I also wanted to make sure that my gut contents were visible. So I was playing with the scalar curve to make sure that I could see the guts and I could see the fish. But now I've displayed the region of interest up here, which is this box where I can use these little nodes to select the slice that I want to cut through the fish to be able to see. What I'm doing here is I'm trying to visualize the inside of the mouth so that the kids can see it. And I also like getting rid of the 3D cube and the 3D axis labels. I also think for certain activities, changing the background to black makes it a little bit nicer contrast and a little easier to see. That's totally personal preference, whatever you like. So now I'm zooming in and just making sure that I can clearly see where the structures are that I want to point out are. So this particular piranha has 2 rows of teeth. So I like pointing out that not only does this fish have the sharp pointy teeth at the front, but a second row of teeth behind those teeth. And this particular fish has lost a tooth. So when we zoom into the gut contents, we can actually see it swallowed its own tooth down there. And we talk a lot about what other objects can you see in the gut? Why can't you see, the soft tissue in the gut? And we talk about how CT scanning works and that kind of thing. And so it just makes it a lot nicer. So you can play around with color, you can play around with the region of interest and really get at whatever anatomy you want to find and make sure that you can do demonstrations as live as you want them to be, or you can do what I've done here and record them ahead of time. It just depends on what your audience size is and what works for you. The other way to do demonstrations with Slicer Morph is to use segmentations. So here I have a snapping turtle from the Whitmer lab, and this is a really nice scan. Not every scan is going to work as nice as this one for this demonstration, but I've gone to the segment editor. I've made sure my master volume is my snapping turtle, and I've added a segment. I've then gone to the threshold section of this module, and I'm now thresholding out just the bone. So you can see the green flashing bit is where the bone is. And I've applied that so that now only my bone is segmented out. Now I go to the islands section and I say split islands into segments. And what this says is anytime there's at least 3 voxels between 2 individual pieces of my segment throughout my slices, I want you to make that into a different segment. And what it'll do is it'll basically make each bone a different segment that you can then change the color of, change the volume of, and play around with all the different metrics. And I'm showing you, I'm talking right now because this is how long it takes to do on a basic, very basic 2016 Mac computer. And you can see it takes a minute or so and you have all that you need. So now all of my different bones are different colors. I've hit the show 3D button. It takes just a second for that to visualize, but once it's visualized, you can hit the little crosshairs button and center it in the frame. You can make sure that the 3D viewer is the only one present. And now I have all of these different bones and it's really easy to move around even on my laptop. You can then go in and make this again as artistic as you want it to be, change any of the colors of the segments. You can change the name of the segments, change this to the carapace of the turtle so that you know what the different parts are. You can, if I could spell, that'd be great. You can play around with different aspects. You could turn the visualization for each individual bone now on or off, depending on how you wanted to go through your demonstration. You can also use the logical operators module to combine these different segments or islands together. So here I'm adding segment 1-2 to the carapace segment, just as an example of what you can do. So when I turn segment 1-2 off, you can now see there's a part of it that is now added to the carapace segment. And so you can link different parts of your segmentation together. You can color them whatever you want. You can visualize them however you want. You can tinker with it here and there. And there's so many different tools in the segment editor to play around with. Those are just the easiest, really quick way to get a nice visualization if you have a fairly decent scan of something that's got very dense bones, like a turtle. So those are the two things that I use the most often when I'm doing outreach in science communication. Just some extra tips that I've learned along the way. Get everything set up and all your windows set up ahead of time so that you can jump into your demonstration if you aren't recording. If you want to use more than one specimen in a demonstration, so for example, when I use the batfish and the piranha, I have them open in two separate windows so that I don't get confused. Trying to turn different volumes on and off is a little confusing. So I just have my different data sets in different slicer windows, and that is very helpful. If you have a group of more than 10 to 15 people, I record and use animations or videos instead of doing the dissection live, because there's just too many people to ask questions one-on-one, and it makes it a lot smoother and run a lot easier. And then for small groups, I do live demos, and I prepare 1 to 2 questions to ask the audience ahead of time, and then to spark some interest, kind of get them understanding how the different 3D volume works. And then I let the audience ask questions, and I'll zoom in or zoom out to the part of the scan that I want to look at, or that would help them answer the question. I also have a bunch of helpful links. If you've never used Slicer before, if you're having trouble importing, or if you have any other questions, the discourse is extremely helpful, and the experts, it's a really welcoming community. There's no shame if you think you have a really beginner question. Everybody there is super helpful. And I also have my email here if you have any specific outreach questions. Please comment below if you have any questions, or reach out to me at any time, and thank you for listening.